So in this video, what I want to talk about is how to calculate Z alpha and Z alpha over 2. And so let's start out by just looking at our typical Z, what we've known previously. So we have our normal curve, and let's just say we have a Z value here. So when we find Z, that means we are finding the probability, we're finding the proportion that is less than Z. So when we look this up in the Z table, that's the value we find. That's the proportion we find. Now, if we are looking at Z alpha, we have our same normal distribution. But now, instead of Z, we have Z alpha, where the alpha is this proportion to the right. So it's just that's alpha proportion. And over here, this is 1 minus alpha. So this is how we calculated Z alpha before. And now we have this terminology of Z alpha over 2. And so it's similar to Z alpha, how we calculated it. And we'll actually calculate it the same way. There's just one little extra step. What Z alpha over 2 is saying is now we have two places here. This is Z alpha over 2, and it's finding this area, and this is Z alpha over 2, and it's finding this area outside here. So the proportion here in this shaded area is now alpha over 2, and this is alpha over 2 also. So now when we have this subscript down here, we know that it's finding the proportion in the tails of the distribution, meaning the tails, not the middle here. The tails are just these end pieces. So if it's just Z alpha, it's a one-tailed, and we're looking to find this proportion here. If it's divided by 2, alpha over 2, that means it's two-tailed, and we want the proportion in the two tails. So the calculations are similar, just the beginning step is going to be different. So to start off, let's look at just how to calculate Z. We'll call this example 1. Find Z equals 1.37. So graphically, this is what it would look like. And we have Z here. That is Z equals 1.37. So what we do to find that is we will come to our Z table, and we'll find 1.37. And I know you can't see mine, so follow along on yours. Pause the video if you need to. What we do when we're finding Z, we come down on the left and find 1.3 and then over to 0.07. So right here, which is 0.9147. So that means 0.9147. And let's do it like this. Let's say Z equals 1.37. That implies, so just drawing an arrow, that we get 0.9147. So that is the proportion here. That says this is 91.47%, and I'm having an issue writing with this pen. That proportion is 0.9147. All right, and if we wanted, we could go ahead and tell ourselves what this proportion is here. We could do that by just doing 1 minus this proportion. So we could say this is 1 minus 0.9147, which is equal to, and I'm doing this off my head, so please forgive me if it is wrong. So you get 8.5% roughly for this proportion to the right. So that's the same idea when we're talking about Z alpha. We want to know the proportion over here, and by doing that, to do that, we find the proportion to the left. So let's look at an example of Z alpha again, just as a refresher. So example 2, find Z, and let's say I'm just trying to find a good number here to use. 0.72. All right, so let's draw our graph first. All right. So what we're doing now is we have our z of 0.72, meaning that we want this portion here to be 0.72. And that means, so what does that tell us about this portion over here? Well, we can do 1 minus 0.72, and that gets us 0.38. I have my z on the wrong side. I should have put it over there, so that's why I paused for a minute. But this will still work. We can still do this. So what we want to do is now just look, we want to find this 0.38 in the body of the z table. So remember, when we're doing z alpha, and this will be the same thing with z alpha over 2, we look in the body. So z, we look, when we're finding just z, we look on the outside edges and find the proportion. Now we're given the proportion that we want in the tail over here, and so we look this proportion up to 0.38 in the body. So we look up in here 0.38, and we get, so this z of 0.72 is equal to, so I'm looking up 0.38 in the body of the z table, and I get, it's in between two numbers. So it's negative 0.3, and it's in between 0.00 and 0.01. So what I'm going to do is just say I'm going to say negative 0. I'm going to say 0.5. So it's in between 0.00 and 0.01. So I'm going to say 0.305. So that's how you find that portion. All right, let's look at one more of those. Example 3. Find z of 0.15. So we draw our graph. And so now I'll draw this on the correct side of the graph. This is z of 0.15, meaning we want this area here to be 0.15 and this area over here to be the rest. So if this is 0.15, we just do 1 minus 0.15, and that gives us 0.85. So that's what we want to look up in the z table, in the body of the z table now, 0.85. So we come in here, and 0.85 is right here, and I'm just going to say it's 1.04. So remember, you come in here and find the value you're looking for. You come over, it's 1.0, and up, and it's 0.04. So z of 0.15 is equal to 1.04. All right. So z alpha over 2 is going to be very similar to this. Let's look at one of those. All right, we'll call this example, let's use a different color here for this. Example 4. And now let's find z alpha over 2 if alpha is 0.1. So what this is, when you see z alpha over 2, what this is saying is now we want to deal with both tails. We want to know what's happening in the tails. So here and here. All right. But I'm not going to write in z right here yet or right here yet. But we want to know what's going on here. But first, we need to do a short, small little calculation up here so we know what values are in these tails. So the way you do that is you take z alpha over 2, that's equal to, and plug in whatever alpha you're given, which is 0.10. So you just plug that in. So now we have z of 0.10 divided by 2, and then just do the math. Z of 0.05. So what that's telling us now is our tails have 5% in them, or a proportion of 5%. All right. So far, that's the new part. So what we want to do now is we want to find here we want to find these z values. We'll just call it z alpha over 2 for now, just so we know we're dealing with two tails. So treat this the same as we did earlier with the z alpha, and just look at one tail only. By finding this tail, we find this tail also, or this z value also. By finding this z value, we find this z value also, because our z table is symmetric. And so if this tail has 0.05 in it, how much does the entire graph have? So treat it just like the z alpha. How much does this entire portion from all the way over here to all the way over here have? It's 1 minus 0.05, which is equal to 0.95. So now that's what you want to look up into the z table. So we want to find 0.95 in the body of the z table. So we come in here and find 0.95, and it's in between these two numbers here. So it's 1.6, and then it's in between 0.4 and 0.5. So we can say that this is equal to 1.645. All right, that's only this z value though. This is 1.645. So the reason we only worried about finding this right tail, as I said this earlier, the z table is symmetric. So if I know both of the tails have the same proportion in them, and I know this z value is 1.645, then this one is just the negative of that one. So this is equal to negative 1.645. All right, let's do one more. At first, I know these can be a little weird and confusing, so let's do our best here. All right, so find z alpha over 2 if alpha is 0.05. You may also hear, instead of it written like this, you may see find z alpha over 2 with a level of significance. Significance of alpha equal 0.05. So that level of significance is a new term. So you may see this instead of this. All right. So just don't get confused. When you see level of significance, it's talking about your alpha value. So it may not even say alpha. It could say find alpha over 2 with level of significance of 0.05. So level of significance is implying that this is your alpha value. So once again, draw our graph. And up here, I should say plus or minus is your answer. So when we're dealing with alpha over 2, we always consider a plus or a minus, or plus and minus. So let's draw our graph. And here is z alpha over 2 and z alpha over 2 with a level of significance of 0.05, meaning that in our tails combined, we want 0.05%. So remember, you have to do the simple little calculation of just plugging in your alpha and simplifying. So z alpha over 2 is equal to z of 0.05 divided by 2. which is z of 0.025. So that's telling me that I want each tail to have 0.025% in it. And same thing over here. All right. So to find both of these values, I only need to find one of them, and I'll just find this one because it's the easier to do. So if I know 0.025 is in this tail, then that means the rest of this has to be 1 minus 0.025, which is equal to 0.995. Excuse me, 975. 975. So this is the value I want to look up in my table. So I'll come in here and find 0.0975, and it's right here, and it's right on the dot. So 1.906. So 1.96. So that tells me this is 1.96, and this z value is a negative 1.96. So this would be plus or minus 1.96. All right. You will have to know how to calculate these by hand, but the most common ones that are used a lot are down here on the bottom of the z table. So look through your z table and look through these, and you'll see some similar numbers that I just came up with here for these two values. You'll see those, but please know how to do these by hand, because I could give you some oddball numbers, and problems in the real world will come up where they're not pretty numbers like over here in the z table. That's it.